Hello and welcome to Venture Robotics, and thank you for joining us for Afternoon Innovators. Today we're going to be talking about circuitry. So, one of the things I wanted to get us familiar with is kind of voltage, current, and resistance. So, one of the things that we can do is we can actually work with the products that we have, but also we need to understand what they are. So, first of all, we understand voltage can either be generated by a power station, or what we can do is we can store it in something like, say, these batteries right here. And for using these, this is actually, if you look on there, there's an actual thing that says there's an actual 3-volt charge on there. But how do we know exactly how much we got in there? Well, so I'm going to be introducing something a little bit more than what we usually have. This is called a multimeter, and we're going to use it several times during the work with this particular unit. So what this does is this allows us to measure voltage, allows us to measure resistance, which we'll talk about that here in a minute, and we'll also talk about amps. So amps are you use each of those things to kind of be able to measure how much you got. So it's one thing to put it together and just see it work, but it's another thing to actually know how much power you're getting out of it and how much voltage is going through. So right now, if we start off with the voltage assessment, let's go ahead and see. I'm going to go ahead and put it down here real quick. But whenever you get it out of your kit, you'll be able to kind of go in, and you have different things here. I'll go ahead and turn on the light so you can kind of see a little bit more. So you can kind of switch in between. There's several different things on here that allow us to kind of be able to see what we got. So if I go up here to this, you can see that there's a little voltage thing. I can turn it off. Go over there, and we got the 600 volts, which we're not messing with 600 volts yet. Anyway, that would be a really high voltage, and I don't even think I think you could probably detect it on these wires, but it would be a very dangerous situation. So we're going to be going down to somewhere along the 20 volt mark, where it says 20. If you look on there, so see that little 20 on there, that tells us that we're actually able to kind of measure what we got. So we'll take that off and get that light on there. And what we're going to do, first of all, is kind of test out and see. We got these two batteries in here. It says it's 3 volts, but all right, take time and pause. Who thinks that it's going to be 3 volts? Okay, welcome back, and let's see what we got. If I go ahead and put my leads on here, we're at 2.86. So depending on what stage your batteries have been at, we always have this thing where if they sit around long enough, most batteries, and you know this, if you sit around long enough, it starts losing charge. So it's actually holding out pretty good at 2.87, 2.86, kind of bouncing around. So let's see here. I'm going to go ahead, and now that we got that, let's kind of build out a circuit here. So that's what I like about these snap circuits, is that they actually have their symbols on there. If you look on there, there's a little thing that looks like a latch. I don't know if you can see that, but the latch is usually what we use for kind of being able to tell whether or not a switch is open or closed. Open switches equal what? Open circuits. Open circuits equal not very much being able to travel around the circuit. So we want closed circuits in order for our stuff to activate, but we don't want to close the circuit in a dangerous situation. Alright, so what we're going to do now is we're going to take this, we're going to take a switch here, we're going to run this to here. We'll go ahead and kind of stack up everything like this, and go through here, and if I put this on here, wonder what happens. Nothing happens, but the problem with this is that we're creating a short circuit. We should not do this. Short circuits are bad because they actually fry out electronics and different things. A lot of times when we're dealing with radios and different things like that, and then stuff that I've had when I worked in the field, we have a short circuit that fries stuff out. So let's try something different here. Let's put something with a little bit of resistance. So I'm going to grab one of these resistors here. Let's go with our nice little 100 ohm resistor here. So I'm going to take the 100 ohm resistor, put it right there, and then I'm going to connect up some stuff. So let's see how much we have going through here. So at 100 ohms, if we put this in, how much resistance comes through here. So we'll go ahead and put this on for the screen. You notice we're at 2.8 still. Didn't really drop that much. So let's go ahead and see what happens when we put in a 5K. So these resistors are registered in this little omega symbol. So if you see on here, when I say omega, we got a little, looks like a little omega symbol at the end of this. What this is this is a symbol that allows us to be able to see, that is called what we call ohms in Ohm's law. But ohms are what we use to measure resistance. And if you have resistance in electrical systems, which we don't really have resistance in plumbing, that's usually measured in pressure, I guess, but it'd be interesting to see if we have something like that in plumbing. Alright, so we did kind of a connection check, and then after kind of checking my priorities, did find out a few things. So we can't put everything directly on the resistor yet. Our resistors are not made to kind of run in parallel like we're supposed to. So we take our leads and we kind of go like this. So we got to go and we hit off of this part over here. So, and I'll bring that in if you want to zoom that in a little bit closer. But we take our two leads, these two guys, and we put it right after the resistance. And so as I do that, by our calculations regarding anything without wind resistance. Alright, handy assistant, could you hold that for me? And so if we take a look at this,
light?
Yep, hit the light again. And so if we take a look at this, I have my milliamps going, and if I put my thing right there, it's saying like it's 0.06. So we got 6 milliamps, which is a lot more than what we're usually used to on going through that. What we should be expecting is like a 0.26, something over there in that, because if you move the hundreds place over, it's something like that. So what we have is we don't have exactly a perfect system, but we're able to kind of measure it out that way. So as we do that, let's go ahead and take a chance to take a look. That's with the 100 ohm resistor. I tried it with the 10K resistor, but the poor 10K, we barely get any milliamps out of that just because the resistance of a 3 volt to the other side of a system would not work correctly. Okay, so let's see here. So let's go ahead and take the motor and we'll put the motor in. So you're used to seeing this type of motor. And so the funny thing about DC motors is they can change direction pretty quickly. This is kind of basic part of a robot. Whenever you're moving a robot around, you want to be able to move direction. And so we can change direction by the voltage apparently. Anyway, so what we're going to do, we'll go ahead and again kind of sample out what's going to happen. Let's kind of take a look at what happens with our amperage whenever we actually hook everything up. So I'm going to go ahead and hook this up, and let's see how much resistance we got. So we haven't done this yet. We haven't done resistance yet. So how do we find resistance? Well, we talked about the ohms on the resistor, but now we got to talk about the ohms over here. If you look over here, there's a little spot over on this side that has the omega symbol, and on that omega symbol you're able to kind of take this and convert it to the places. Now I don't think we're gonna have too much. I would go over and put it, you know, you got like 200K, 20K, and a whole lot. Let's go ahead and put it on the second notch, or maybe even to the bottom notch, which is 200, and see what we got there. If we start having 200 on our resistance, then we're going to get very low current now. So, assistant, can I have your hands, please?
Yes, you can.
All right. So go ahead and hold that up there to the camera, and let's see what we got on our ohms reading. So we go ahead and hit this out. So what do we got for a reading on there? It's all over the place, but that's completely normal. So we got somewhere between 118 and 140 on our ohms resistance. So probably what happens is whenever we turn this, if we were to actually turn our motor by hand, it would actually change. And so now look, we've actually gone to quite a difference. So I'm going to go ahead and see if I can actually get a solid connection there. So now it looks like we got like 50, is that like 55 or what is that?
It's about like 50, or it's about like 51. The least I've seen is 51, and then the most I've seen is about like 60.
Okay, so at a 60 run, that's how much resistance we're putting in. So hopefully we get a little bit better amp reading. What were we getting on the last one when we were going through? It was like a 0.02?
Yeah, or it was like a 0.06.
Yeah, 0.06. So let's see what happens whenever we turn this on. Let's do a test. So we got everything over in the milliamps. Again, 200 milliamps. So now, let us throw the switch. So we throw the switch, here you go. And now, go ahead and show that resistance up there. We'll show so I get my leads. We always want to have the positive closest to the motor and the negative closest to the negative side. And so look at that. We got, it looks like a 0.017, right? Whereas we only had like a 0.06 on that last run. So we actually got better amperage going through the motor, and you can actually kind of tell whenever I actually put it on there, and you can actually feel the resistance on that. That allows us to kind of see, oh, there's something in there that's going parallel, and so that's happening. So let's go ahead and do the usual. Assistant wants to go ahead and do the propeller test. So funny thing happens when we put these things on. So if we have it going in reverse polarity, which here, let's kind of take a look at this real quick. Polarity means which way, which direction our current is flowing. Kind of like your north-south on a compass. So if we have the positive going over in the positive direction, it's interesting because let's see what happens. So if we have the positive going towards the positive side of the battery, if you look on our battery here, if you look right there, there is a positive indicator showing which way it goes. Now, funny fact of history, we actually got the signs backwards. So if you were to actually look at which way the electron travels, the electron is actually shooting through the negative side, going back and traveling back to the positive side. That's how they've been able to kind of test that. So, look that up sometime. It's kind of fun for me. So, we're going to go ahead and hook this up. I'm going to hook it up with the positive side first. And what say you happens with this little propeller blade? Do you think it goes forward? Do you think it goes back? I'll give you a little bit of time to think about it.
I think it would go the direction it would go if it were on positive.
That's not up or down.
Up.
And wait for it. And go. So right now it's holding its course, so we can't really say whether it's doing anything or not because of which way it's going. So the whole thing is, we also have to figure out which way, if it's turning, is the air going. So right now, got a little bit of a breeze there, and it's actually going up. So
if I were to put a piece of paper right there, that paper would just kind of be
right. So what we're going to do is we're going to take it, we're going to stop it and see which way the inertia lets it go. So we stop it right here, and all right, what do you think it's going to do? Is it going to go up, down, or off? Ah, disappointing. So, now again, start off with polarity. So, funny thing is, what were we setting at assistant on our polarity when we were reading? It was 0.016 milliamps?
I think.
Yeah. So let's see what happens. Do you think that if we reverse polarity is going to change anything on our current read? Let's see what we get. Alright, need you to hold up the meter and let's see what we get off of this. So, here we go. And we're turning on the power. And what are we reading right now? Oh, 0.12. So it makes me wonder, is our voltage getting lower? Probably. We've been running this a lot. Let's see, so if we go ahead and switch over to voltage, you want to switch it over to voltage and see what we get?
Voltage.
So it'd be V over here. Probably where the 20 is. Okay, and so now, ooh, 2.7 and 5. And still holding on 2.7. So we were where did we start off at?
I think it was like.
Let's cut off and see if we go and bounce back to 2.8. Yep, 2.81. We started off at 2.9. Okay.
Hey,
so,
Dad, what if we did the motor with the reverse thing on?
Okay, so here we go. So now, turns out that we're actually pulling a little bit more on the amperage, a little bit less. That might be because of our voltage going down because of what we got. But let's go ahead and do a test on this and see what we get. So we're going to go ahead and fire up. So now we're in reverse. What's going to happen? Is it going to go up or is it going to go down? Why don't you hook it up and find out. And away we go. And we got some air going. Looks pretty smooth. And now. Alright. So it did exactly what we needed it to. So, one of those things where we go back and forth and test out again. I always like to test it twice, see if it happens again. Now the thing is, this is only running with 3 volts. Each one of these packs represents 3 volts, so if we add 3 volts, 3 volts, 3 volts, you can actually only go up to 9 on this thing, because we've actually tried to go to 12 and that was kind of dangerous, so we ended up almost burning out a motor. But that's pretty impressive for just having 3 volts to be able to shoot something in the air. So, next thing that we'll try to do is kind of go through and get all these things set up. I will have some other things for you to go through and try out. I want you to just kind of test some things out, try some things out. See what you get on your measurements.